The image should have been routine. The system had already approved it. An analyst opened the frame expecting another quick review. Instead, there was a mark. Small. Easy to dismiss. The problem was not seeing it. The problem was seeing it again. The first assumption was simple: a transmission artifact, a sensor glitch, something introduced after capture. A second image was checked. The mark was still there. A third pass arrived later. Different lighting, different viewing angle. Still there. At first, nobody treated it as a problem. An operator repeated the verification sequence by hand, while other reviews continued around the room. The system flagged the anomaly again. Then again. That was the contradiction. If the error existed inside the imaging process, it should move. It should distort. It should disappear when the spacecraft returned. It remained. More observations from the same region were pulled into comparison. The feature appeared where it should not have appeared, not once, repeatedly. The review shifted from routine validation to something slower. Images were rechecked. Calibration records were reopened. The possibility of a software fault was examined first, because that explanation was easier to manage. But the detections kept arriving. Not dramatic, not catastrophic, just consistent. By the end of the review cycle, the anomaly was still sitting in the same place across multiple passes, while a request for independent confirmation moved up the chain. And on the latest image, the mark was waiting, exactly where the previous one said it would be. The second look makes the first look harder to explain. More passes from the spacecraft began arriving from different observation windows. The request for confirmation had worked. There was more data now. That should have helped. Instead, the comparison boards became harder to read. In some images, the anomaly looked larger. In others, it appeared narrower. One pass suggested a sharp boundary. The next suggested no boundary at all. An operator started arranging the images manually instead of relying on the automated comparison tools. The software kept grouping frames together that no longer seemed to belong together. The assumption shifted again. Maybe the original detection was real. Then another set of images arrived and weakened that conclusion. That was the problem. If additional observations were revealing the same object, the appearance should become more consistent. But every new pass seemed to introduce a different version of it. The system was producing evidence that disagreed with itself. A technician reran part of the image registration procedure because several frames no longer aligned the way earlier records suggested they should. Nothing failed outright. Everything kept functioning. Trust was what started slipping. By now, the question was no longer whether the anomaly existed. The question was whether anyone understood what they were actually looking at. Across multiple observation windows, the feature remained present while its appearance kept changing. And on the latest comparison screen, 4 images of the same location sat side by side, each showing something slightly different where the anomaly was supposed to be. The hardware works. The agreement does not. Teams began pulling data from other instruments connected to the mission. What had started as an image problem was now moving into diagnostics. The spacecraft reported normal status. Power, temperature, and pointing accuracy all remained inside expected limits. Nothing in the health report suggested a failing system. That should have simplified the investigation. Instead, it created a new problem. One dataset suggested the anomaly was becoming more defined. Another suggested it was weakening. A third indicated no meaningful change at all. An analyst compared the reports side by side and reached one conclusion. A second analyst reviewed the same material and reached another. Neither interpretation could be dismissed easily. That contradiction kept growing. If the instruments were healthy, their observations should begin aligning as more information arrived. Instead, the gap between them widened. The mission was no longer struggling to collect evidence. It was struggling to decide which evidence deserved trust. Routine procedures started taking longer. Verification chains expanded. Reviews that normally required one approval now moved through several. People were not responding to failure. They were responding to disagreement. And disagreement spreads quickly through a system built on coordination. The spacecraft continued sending data exactly as expected. The ground systems continued processing it exactly as designed. Yet the conclusions kept drifting apart. By the end of the shift, several independent datasets remained open on the same investigation, each pointing toward a different explanation. And on the decision board, no one could say with confidence which system should be allowed to lead the next move. For a moment, they think the problem is solved. After weeks of accumulated analysis, the competing interpretations finally began narrowing toward a single explanation. The review meetings became shorter. The disagreements became smaller. Models were updated. Forecasts were generated. The investigation started moving forward again. That mattered. The mission did not need absolute certainty. It needed enough confidence to make decisions. One team committed to the new explanation and tested it against previous observations. The results were encouraging. Most of the older inconsistencies could be accounted for. Reports were revised. Documentation followed. For the first time in a long while, the anomaly appeared to fit inside a coherent framework. Then a new image arrived. At first glance, it looked routine. An operator loaded it into the comparison sequence, expecting confirmation. Instead, the prediction missed. Not by a little, by enough. The feature appeared where the model said it should not appear. Its shape differed from the expected progression. Several measurements moved in the wrong direction at the same time. The room did not react immediately. People checked timestamps first, then processing logs, then alignment procedures. The explanation had become trusted enough that the image itself was treated as the likely problem. But the verification completed. The image remained valid. That was the contradiction. If the model was correct, future observations should become easier to predict. Instead, the newest observation broke the prediction completely. Then the spacecraft produces evidence that says otherwise. The explanation survived weeks of analysis. It survived review. It did not survive reality. And by the end of the day, the newest image sat alone on the comparison board, while teams argued whether the observation was wrong, the model was wrong, or the process used to verify both could no longer be trusted. The spacecraft continued its passes. Data continued arriving. Processing queues continued moving. From the outside, the mission looked healthy. And eventually, operations resumed. Not because the anomaly had been explained, because the mission could not remain suspended forever. New procedures appeared first. Every observation now required additional checks. Independent reviews became routine. Comparisons that once took minutes now took hours. People adapted. The system kept functioning. That was never the problem. Operational survival should have restored confidence. Instead, it created dependence. Each successful observation required more verification than the one before it. Future missions inherited the changes. Documentation expanded, review chains lengthened. Extra validation steps became part of normal procedure. Nobody described this as a failure. It looked like improvement. It looked safe. Yet underneath the new process was an uncomfortable reality. The mission had learned how to operate with uncertainty. It had not eliminated it. Years later, the anomaly remained part of the record. The spacecraft continued working. The procedures continued working. The institution continued working. But every result now carried an additional question attached to it. Not whether the data arrived, whether anyone had verified it enough. And somewhere inside the processing chain, another image was already moving through yet another layer of confirmation before anyone was willing to trust what it showed.